Hey guys, how's everyone doing today? Hopefully you guys are all having an amazing day so far. Welcome to my third episode, even though I don't name it episodes, but welcome to my third video in the Homelab series. Today we will actually be talking about actually creating our first server, and it's going to be our DNS server. So for those of you guys who don't know, a DNS server is pretty much just a name solution server. So like, for example, say when you go to www.google.com, you end up being on Google's website, right? But in this case, essentially this is more for our internal stuff, just for our home lab. So say for example you build like a GitLab server where you want to be able to type in like gitlab dot something something.com. Then it would actually redirect to your server instead of needing to make a public DNS entry. So this makes it's a really good way to kind of centralize kind of your own home lab stuff, making static IPs and making sure that you can resolve by name instead of by IP. So here we go. This is going to be our third video. This video is also sponsored by me, myself, and I. So if you're interested in doing a sponsorship with me, feel free to check out in the description. So send me an email, and we'll see where that goes. So hope you guys enjoy the video, and we will get started here. All right. So as we kind of first started, in our previous videos, we uploaded an ISA and created a virtual machine from it. So from that, I actually created a VM from that virtual machine. So what we're gonna do here, we named it Dragon DNS1. You can name it whatever you want. There's just names that just kind of help you make it make sense. They're all up to you at the end of the day. So we're gonna power this on here. And we will let it boot. So DNS is nice because essentially every single website is actually hosted behind an IP, right? An IP you can think of as like a home address, for example. You can have they're supposed to be all unique. So, for example, when you mail something to someone, it will always go to a specific address. You won't have like two addresses be the same, and the mail carrier doesn't know, hey, which address do I send it to? That's what essentially IP addresses are in networking. They're unique IP addresses that allow you to essentially be like, this is where I want to go. So, first step that we want to do here is, because this is a template. And I typed in the wrong password too. We want to convert this template into, we want to use a different IP and a different host name for this template. Because whenever you create another VM from the same template, it will reutilize the same IP, reutilize the same host name. So it makes it very hard to kind of manage and review, what you're doing. So in this case, we will update the network scripts. Network interface. Instead of 1.30, we'll have our DNS. We'll have our DNS be 1.31, and I accidentally hit 1.131. And as well as the host name, we will set the host name to be Dragon DNS1. Hostname CTL. Okay, so now we'll reboot it, and when it comes back up here, it should essentially just pick back up the new IP as well as the new host name. So now you can see it says Dragon DNS1, and if we do an if config, it shows that it is using the address 192.168.1.131. So we are all set with that. So with Linux, and there's multiple ways you can use DNS. You can set up like an Active Directory server and do DNS stuff, but I personally like just using Linux. It's pretty bare bones, really simple install. You just kind of download some packages, set up some configs, and it works. So with CentOS, essentially what you will be installing is bind. And bind utils. So bind utils is another essentially package that gives you good kind of DNS things, like using like dig and a few other things, commands that makes it easy to troubleshoot or validate that you're actually doing DNS correctly. So we'll install bind and bind utils here. Okay, so now that we have that installed, we will actually start named, which is really funny because um, bind's the package, but named is the service, right? So like when you think about it, you're like, oh well, that doesn't make much sense. So you can see we see it's running. Okay, so we'll also enable it so that when it boots up, it will also run on boot. So now that we have it running, you can do like a netstat, and you can see on the local address 127.0.0.1 on the first line, :53, named is running, and it is listening on itself. So the few things that we'll need to do is essentially update the config so that essentially any server on my home network can actually query the DNS, because right now only it can query itself. So what we're going to do is actually edit this. So what we want to do is actually comment out these lines. And in this case, you can comment out just doing double slashes. So essentially, instead of just listening on port 127.0.0.1, which is essentially localhost or home, it's going to just listen on all on 0.0.0.0, which is pretty much anything. But we'll only allow servers in our network, which is the 192.168.1.0/24, to actually be able to query. So essentially, even though we're opening it up to everyone, only my home network can query this server. Now, those are the only things that you need to do up there. What we'll also do is we'll actually add 2 zones. So we're going to make a dragon.local zone, which is essentially like your domain, like google.com, that's a domain. In this case, we're going to make dragon.local to kind of make it work. So what we're going to do is create a zone. And this is the forward zone. We'll also talk about reverse zone lookups in the next part too. So we're going to make it called dragon.local is the zone. It will be a master. And so you have like master and slave. So you would essentially have master and slave is how DNS terms it from like primary and secondary. So say for example, you want to have, high availability DNS, and if your main DNS server goes down, your secondary one works. So that's how you define, hey, is this a master or a slave server? In this case, we're just going to do master server. We're not going to do any slave servers in this video, but we might do one later, just because if we want, when we talk more about high availability and how to handle certain things like that. So we got master, and then we need a file. So in most cases, most of the files will be located in var named data. In this case, we will create the file called dragon.local zone. You can really name it anything, but you want to probably name it something that actually is relatable to what the zone name is, right? Because you don't want to get confused. So essentially, that should be it for that zone. So now that we have the forward-looking zone, now we need to create the reverse zone. The reverse zone is nice because, say for example, you're like, hey, I know what the IP of it is. I know the 4 octets, but I don't know what the name, what it resolves to from a like. Does it resolve to google.com? Does it resolve to like facebook.com? I don't know that, right? So creating the reverse zone, you can do a lookup of the IP, and it should tell you what it would resolve to, right? So in this case, we're going to create that too. Because this is my home network, usually you always do reverse zones to be like this, where in this case, it's my IP address for my home network is 192.168.1, right? Reverse zones, you usually type it in backwards. So in this case, we do 1.168.192, and then in at our opera. It's usually kind of the default naming standard when you come to DNS stuff. If you're interested in why it's like that, feel free to Google it. Okay, and then we'll also do the same thing, 168.192.zone. Here, and then allow update none, and there. So that should conclude what we need to do in regards to the named file. What we want to do next is actually create the zone file. So in this case, named data we actually have to create it, and I need a dragon.local.zone. Okay, so this is where it's a little bit more interesting, and I'm not going to explain every single detail in regards to like what every single parameter is. If you're interested, you can also Google search it or chat GPT it, up to you. But I'm essentially going to go with what the default setup is for what a hosted zone would look like in Bind. But you can just kind of just take it as more of a general template here. So first off, we'll have TTL 86400 at the top. We'll have in a SOA, and I can't even remember what SOA actually stands for again. It's been a little bit. I still remember when I first had to take my test in regards to this. I went, I don't know what SOA stands for on the test, because that was like the only question I didn't know what it stood for. Actually, we'll just even look it up. Start of authority. There you go. That's what it's called, guys. I still don't remember it to this day, but I just know that it is the thing. So, we will name it dragon.local, and then we have root dragon.local. Oh, and I need the dot here. Okay. So the next part is essentially the parameters for the DNS entries. This can comprise of like the refresh period, retry, minimum TTL, things like that. So I'm just gonna give general just numbers. For the most part, you can copy and paste the numbers. Still should work at the end of the day. And in this case, the first number is the serial number. So there really isn't. What's today's date? 34th? Today's the 4th. Wow, July 4th, guys. And I think I need one more digit. Yeah, we'll add a 0 to that. So the first part is the serial number. The serial number has to be unique in regards to every single time you change this file, right? So the reason for that is when the file changes and you restart the service, unless you change the serial number, it'll be like it's the same file. Because essentially it looks at the serial number and goes, hey, is this a new unique identifier? If yes, reload the config. If no, don't even touch it. So that's one thing to know. And I've always ran into so many times where you update the zone and you don't update the serial, and you're like, why didn't it refresh? And it's because you have to actually update the serial number. What I usually do, and it's up to you, it's personal preference, I usually end up doing the date in which the day I last updated it is, so that's why it's easy to kind of read and remember. The other way to do it is you can just increment the serial number by 1 every single time, and until you, I guess, run to 9,99999, you're fine. So most likely you'll never run into that unless you're updating the zone like a lot, which really doesn't make much sense because you usually only will update it once you ever add a new machine, delete a machine, or need to, move a machine to a different location. So the next thing is refresh. Then we got retries. Then we got expire. And then we got minimum TTL. And minimum TTL is is another thing I will actually talk about. So TTL is time to live. This number is always in seconds. So if you look up 864 seconds, 2 hours, this should be 24 hours. Yes. So essentially, DNS does caching. So essentially when DNS is cached, it will essentially just use the cached value until the time to live expires. This makes it so that it's better when you have to go to a website that it's cached instead of having to go out and retrieve, hey, I need to query again, for google.com. Instead, it's, hey, I already know what google.com is. I'll just give it to you, right? So caching is a good way to essentially make it quicker for a DNS service to respond to essentially queries that maybe hit like a million times a day, right? The thing is, you have to be careful with the TTL. So, say for example, you're running into a case where you need to switch to a different server for your production website, and the problem is you need to update the DNS record because it's a different server IP. If you have your TTL to be 24 hours, it means it can take up to 24 hours before every single computer or thing that may have queried this before takes into effect. So someone could still be actually hitting the old site because it's cached for 24 hours. You can obviously drop this down to be a lower time, to be like 60 minutes or like 5 minutes. The reason why you want to keep it up higher is because the more requests that a server gets and less caching it does, the more resources it takes, and it's a little bit slower because it has to reach out every single time or in that period for the new request. And at the end of the day, you should keep it up to at least an hour minimum, in my opinion. But 24 is usually the default. In the case that you don't really know what you're doing, just do 24. But know that in the end, you might have to wait 24 hours before something repropagates because it's cached for 24 there so far. So now what we have is essentially that. Oh, dang it. I had caps lock on, guys. Now that we got all the configuration pods for what the zone should be, and essentially you can have different zones that have different refresh periods, right? So now we need to name the name server. So in this case, this is the name server is actually going to I'm just going to call it DNS Dragon.local, right? And then here's the fun part. Here's the part where we can essentially pick, hey, what is our IPs for what? So in this case, we'll have DNS. Actually, we'll name it. We'll just name it DNS. So we know that this DNS server is going to be 131, right? We also have a CentOS 8 template, which we know it's at 192.168.1.130. So let's put it in there too, right? So essentially, by creating this, anytime that you type dns.dragon.local, it will resolve to 192.168.1.131. Same thing for the CentOS 8 template. If you do CentOS 8 template.dragon.local, it will resolve to 192.168.1.130. So that's how DNS is essentially set up. So now we'll do the same thing, but we'll create it for the reverse DNS zone. So essentially it's saying, hey, if I do a DNS lookup on 192.168.1.130, it should come back as CentOS 8 template, which will be what I want, because sometimes you're like, oh, when you look at networking stuff, it'll give you the IP, but not necessarily the host name. And you're just like, I don't know what that host is, which makes it a lot harder to troubleshoot, right? So that's why you always want to create the reverse DNS entry also. So in this case, we'll create this .zone. So essentially, similar config at the top. We got the TTL for 86.400. We got the start of authority. DNS Dragon.local, Dragon.local, and then today's date. We'll add a 0 to the end of that. That's the serial. We got the refresh period. Refresh. Ooh, just says fresh. Refresh. 800. Okay, yeah. I guess the space doesn't matter, but based off the config I'm looking at on my current server, I don't have a space, so we're not gonna put a space there. Then we got 64800 on the expire, and then 86400 on the minimum TTL. Okay, So that's set again. Then we enter the name server configuration. So the name server is, again, just the same server, DNSDragon.local. Then we got the reverse lookup for name server. So in this case, we know that it is 131. So essentially, because the file is named 1.168.192, it essentially does the opposite. 192.168.1.131. So you don't have to enter the full address, just the last octet. And instead of an A record, it is a pointer record. Hence note the PTR instead of A. Dragon.local. And then we got pointer record IP addresses to host name. And in this case, we got 130, which was the CentOS template. Okay, the other thing to note, and I failed this when I first started, is when you do pointer records, you gotta put a dot at the very end of the domain. So you see how I have CentOS a template .dragon.local . You need the dot. The dot actually matters. If you don't put the dot, you're going to struggle because it won't work. Okay, so now that we have that set up, we can actually do, I think, and it's been a while, I don't know if the conf check actually works as well. Okay, so actually it does still work. So on line 19, I am missing a semicolon. So let's make sure I got that semicolon in there. Yeah. Oh, yeah. So there should be a semicolon right after the /24 here. Okay, so that's good. We'll also do it for our hosted zones. Unless I did it wrong. I don't think it should have errored like that, but let me... Oh, okay. No, that's fine. That's actually fine. I've actually never used it on an actual hosted zone. But it does actually error that. So, but let me... The unexpected token, I don't know if I did the last part right. So let me just double check that here real quick. Yeah, no, that looks right. Okay, that still looks right. Okay, no, that looks right. If it errors, it'll error. Okay, so we can restart name. Actually, so you can restart the service, or you can do an RNDC reload, which is just reloads the zone, reloads the config file. Volag messages, you essentially just see volag messages in here. Okay, so you can see at the about 4 lines from the bottom, it says zone dragon.local/in loaded. That is exactly what we want. Except for the top, well, it says zone 168 master removed. I don't know if that's actually right or not. Oh no, it says it's loading farther down. Okay, so we're good. So both zones are now loaded. So in this case, what we should actually be able to do is actually dig at and actually do, like, for example, CentOS a template.dragon.local, which you can see now it actually resolves and shows that the CentOS 8 template resolves to 192.168.1.30. You should also be able to do the same thing. 192.168.1.30, and that failed. I don't know why that failed, honestly, at this point. The reverse DNS zones are actually a little bit... God. Nah, I don't know why that failed, but we got the forward one working, guys. We can go. I'll go back later and figure out why the other one, why the reverse isn't working, unless I made a typo. Give me a second. We're not gonna troubleshoot it that much. Oh, unless. Oh, it's actually not even working on my current server. In other words, I don't know how to set it up apparently, so we're not going to worry about that. We'll worry about that on a different day. But you got the other way working correctly, and that's what's important. So now that we have DNS set up, what we'll want to do is essentially go and fix our virtual machine template to actually start using that DNS server. To do so, we can just, and I'll show you in here, so I won't actually pull it up, but I'll do it later. We should be able to edit the network config, and instead of pointing the DNS server to 8.8.8.8, we'll point it to 192.168.1.131, which will essentially be like, hey, this is what I want to do. The other thing that you can do is essentially in etcresolve.conf, you can actually, oh yeah, so when it restarts, it'll actually set the name server. Okay, actually, so what we want to do here, so we set it to the name server as well as domain. So the search domain in here makes it so that you don't have to type in the fully qualified domain name. So say for example, I wanted to do like SSH DNS instead of SSH DNS.dragon.local. By doing the search domain, essentially it will always search with the full domain, even if you don't put the full domain in. But you can still use the full domain. Okay, so network. So we will start network manager. We should now be able to see actually in etcresolve.conf that it actually now points to the current name server. The search domain is Dragon. So actually I can just now do SSH DNS. So you can see how it says the authenticacy of the host DNS, which is 192.168.1.131. Essentially will log into this exact same server. You can still also do DNS.dragon.local, so it will still give the 192.168.1.131. So regardless, if you have it in this, if you have it in the search domain, you can do both. But if you don't have it in the search domain, that dragon.local that's there, it won't actually work. Just typing in DNS. So that pretty much concludes the video on how to set up a DNS server. Hopefully you guys enjoyed the video, learned a few things about DNS IPs and how to set one up on a Linux box. In our next video, we'll probably build another service and also utilize the DNS box to kind of show you how it all works. So if you did enjoy the video, please leave a like, comment, or subscribe, and we will see you guys all in the next video. Thank you for stopping by, guys. Have a great day.